Friends, in today's class, we will discuss the importance or the significance and the applications of Bernoulli's equation. What a Bernoulli's equation is P by rho z plus V square by 2z plus Z is equal to constant. So this is Bernoulli's equation. So it states that sum of three energy like pressure energy, this is pressure head energy, and velocity head and potential energy. The sum of these three energies is equal to constant at a particular point or at a particular section in a pipeline. For example, this is the pipe in which some fluid is flowing through this, some liquid like water, oil, any liquid. So if you want to calculate the pressure or the total energy at this particular point, so you apply this Bernoulli's equation. So sum of pressure energy at this point, sum of velocity head, and sum of potential energy, that is equal to some constant, some value. That is Bernoulli's equation. Now, if you apply the Bernoulli's equation between the two sections, let us take one more section in the pipeline, section 2. Now, I will apply the Bernoulli's equation at point number 1, that is P1 by rho z plus V1 square by 2z plus Z1 is equal to, again, the total energy at section 2 we need to consider. That energy is P2 by rho z plus V2 square by 2z plus Z2. And there will not be any losses considered in this particular pipe. If the losses are considered, you need to add the extra term here plus losses. So for time being, I will not consider any loss. I will assume it is ideal fluid. Ideal fluid, there is no losses. So now here, what is the importance of application or importance or significance of Bernoulli's equation is, using this equation, you can calculate any one velocity V1, or you can also calculate V2 when we know pressure terms and potential energy. Okay, and or also calculate P1 by rho g value, that is pressure head at point number 1 at section 1, or P2 by rho z at point number 2 or section 2. So usually in the industry, what they do is they will fix one pressure gauge at point number 1. For example, here is a one pressure gauge. It gives the value of pressure at this point 1, and here also some pressure gauge is fixed. Or you can use a device called manometer. The device differential manometer is used for measuring pressure difference between these 2 points. That I'll be discussed in previous classes. Okay, so using the manometer, you will get the pressure difference between P1 minus P2 by rho z value. And for the given pipe, for example, it is a horizontal pipe. From the datum line, this distance, that is inlet and the outlet, are at the same height. Inlet point and outlet point, or inlet section 1, section 2 are on the same level. So the potential energy is also get cancelled. So it remains only in terms of V2 square minus V1 square by 2z. Okay, by using the continuity equation, discharge is equal to A1 V1 is equal to A2 V2. A1 V1 is equal to A2 V2. I will express V2 in terms of V1 and substitute all the values of A1, A2, and V1 also in terms of V1, you will get in terms of V2, or V2 in terms of V1, and substitute here. You can calculate the value of velocity at the section 2. Once you calculate the velocity at section 2, use the equation discharge is equal to area multiplied by velocity at point 2. So once substitute the value of V2 and area at section 2, you can calculate the discharge. Okay. So finally, what is the conclusion is, the Bernoulli's equations are used for measuring discharge. Finally, you can calculate the discharge. Not only discharge, here using the Bernoulli's equation, we can calculate the velocity also. If all the no values are known, velocity, potential energy at inlet, similarly at outlet, then also you can calculate pressure energy. Okay. That is the importance or significance of Bernoulli's equations. So in point wise, I will say Bernoulli's equations are used for calculating velocity or pressure head terms, and also used for calculating the discharge, means amount of water flow rate or volume of fluid flowing through this particular pipeline. Okay. Now, what is the practical applications of Bernoulli's equation is there are some devices which works on the principle of this Bernoulli's equation. For example, the device's name is Venturimeter, and Orificemeter and notches, okay, nozzles, etc. So these are the devices which are used for measuring the discharge or quantity of water flow through a pipeline. Assume here some water is flowing. It will be very difficult to determine the pressure and velocity like that. So the venturimeters are some devices. Using those devices, we can calculate the discharge through this pipeline. It is Q. And the venturimeter, orificemeter, notches, nozzles, etc. works on the principle of this Bernoulli's equation. Okay, so this is what the brief significance or applications of Bernoulli's equation. In the next video, what we'll study is we'll learn the construction and working of an venturimeter. Okay, so thank you so much for watching this video. Take care. Bye.